Howdy everybody, it's Miss Kosh. I wanted to talk about the discriminant, and I have another video, but I realized that that video doesn't quite do everything that I want it to do, and it doesn't work the very first of these problems. Oh, that's okay. So let me introduce things right here. So if you remember, whenever we have ax squared plus bx plus c equals 0, we can use the quadratic formula to solve for x, and so that we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, sorry, you got to endure my singing. So in this formula, we have this plus or minus, well, so it's possible to get two answers. Okay, so we could have, we have this plus or minus right in here that enables us to then, we could have negative b plus that square root sign or negative b minus that square root sign. So there's a few things, well, so that what we've done is we've called that part the discriminant, and they like to use that triangle, which is the Greek letter delta. And so this b squared minus 4ac is the discriminant, or it's that part that's under the radical, because this is what should be, the square root of this is what you'd be adding or subtracting. So it lets you know if there's going to be two real answers, if it's going to have two non-real answers, if it's going to have a repeated root. So this can be really helpful for us. Like if I have x is equal to negative b plus or minus 0 all over 2a, well then I just have that x is equal to negative b over 2a, which what that does for us is it tells me that my quadratic is going to bounce. So it's either going to, okay, I didn't draw that well. It's either going to bounce and have one value on the x-axis and everything else is positive, or it could do something, man, these are terrible parabolas. Pretend I can draw it correctly. Or it's going to do something like this. Technically though, if I said y is equal to x minus 3, that means that I've got a line, I've got 1, 0, and that 0 is the point 3, comma 0. If I plug in 3, I get 0 for y. And so we're doing something, pretend I can draw a straight line, marginally. Okay, but this has one root. There's one root right here, it's that point 3, 0. Well, if I have this, y is equal to x minus 3 squared, this doesn't technically just have one root. It has one distinct value that shows up twice. Okay, so you'll notice with these, it still has that point 3, 0, but it's going to bounce right here. Pretend I can draw a parabola. Okay, I've done worse. I've also done better. But so these are not the same. So I want to make a distinction. This would be one root, and this would be one repeated root. Okay. HL, we're going to talk about the multiplicity when we get into polynomials. SL, we don't do polynomials, so there's that. But then this root, we could say that this root has a multiplicity of 2, or it's repeated right there for us. So what happens here is when the discriminant equals 0, we have one, when the discriminant equals 0, let's write a whole sentence. We have one repeated real root. Okay, when the discriminant is greater than 0, that means, when the discriminant is greater than 0, that means I have this x equals negative b plus or minus the square root of something positive over 2a. Okay, and so if it's something positive, then I can take the square root of a positive number and get a real answer. So I'm going to have negative b plus something the square root of something positive, so plus a square root of some sort, and I'm going to have negative b minus the square root of something. So I'm going to have two real roots. Okay. In particular, if the discriminant is a perfect square, then not only do I have two real roots, but they're rational roots also. So basically, like if I have negative 4 plus or minus the square root of 49 over 4, I don't know, I just made something up, then this would give me it would give me two possibilities. It would give me negative 4 plus 7 over 4, which would be equal to what, 3/4? And it would also give me negative 4 minus 7 over 4, which is, oh, it's too early in the morning, negative 11/4. Notice both of these are rational values. So if the discriminant is positive, then we get real roots, but it could have been something like negative 4 plus or minus the square root of 47 over 4. Well, I don't know the square root of 47 off the top of my head. I know it's a little bit smaller than 7, but, you know, that's not very helpful. So they're not this would not be this is not rational, but it's still two roots. And they're both real. These are not only are they real, but they're also rational. Okay, that got a little bit much there. Okay, so we have one repeated real root when it's equal to 0. When it's positive, we have two real, what word? Oh, yes, okay, I just remembered. They like to say, not only do we have two roots, but we even said a minute ago that this scenario over here, it has two roots, it's just the same root twice. So we're going to say we have two distinct real roots when it's greater than 0. Okay, so that's going to look something like, hang on, let me come down here. That's going to look something like this, or it could look something like this, where it's going to have 1, 2 roots, or if it can be, you know, going down, it could have 1, 2 real roots like that. So they're distinct, they are not the same. This one right here, it's one repeated root, or it's two roots, but they're not distinct roots. Okay, then we have one repeated real root. When it's less than 0, that means that all of this mess right in here, if that's less than 0, if that's negative, now we have negative b plus or minus an imaginary number. Okay, so then this is non-real, and for HL, you do have to deal with that. SL, we keep it real. So SL, everything we do is going to deal with real values. So I might still ask you to tell me about that, but I'm not going to ask. SL's not going to have to do many problems with that. I might ask you what interval it would give you non-real solutions. So we're going to say, oh, I didn't write a complete sentence here on this one. When delta is greater than 0, we have two distinct real roots. When delta is less than 0, we have two non-real roots. And sometimes I also want to include this. When delta is greater than or equal to 0, we have, wow, that's terrible. My brain and my hand, we're not in sync. When it's greater than or equal to 0, that means we could have this scenario here, or we could have this scenario here. So what we'll say is that we have two real roots. They might be repeated, but they don't have to be. Okay, so the difference between this right here, that delta is greater than 0 versus delta is greater than or equal to 0, is the word distinct. If it's just greater than, then they're not only are there two real roots, but they are two distinct real roots. When it's greater than or equal to 0, we have two real roots, but we don't know if it's distinct or not. Okay, now I want to work through, I think I have a video for this one, so let's pick a new color, red. Let's do this one first, and then I'm going to send you to the second video to watch the other one. So on this one, they don't give us a nice, pretty quadratic equation. Well, they do, but it doesn't have all its pieces. So like back here, they'd say, describe the nature of the roots. Oh, let's do one of those. So I have, the discriminant is negative b, so negative 6, plus or minus, I lied to you. Ooh, b squared minus 4ac. Ooh, goodness. Okay, b squared, 6 squared minus 4 times a times c. So this is 36 minus, what is that? 32 times 3 is 96. Oh, okay. Well, the takeaway is that this is negative, and so this has non-real roots. I think I have an answer key posted for you for these other parts, so go check that out. But that's what we would do. So the discriminant is equal to b squared minus 4ac. Maybe I should have written that first. So this next part doesn't give you the entire equation. They're giving you a value of k, and they want to know, okay, Okay, K, by the way, is our favorite letter. So they want to know what values of K give you different scenarios. So if I plugged in different values of K, when would I have two distinct roots? When would I have just two real roots? When would I have a repeated root? When would I have non-real roots? That kind of stuff. So what we need to do is we need to look at the discriminant, which is b squared minus 4ac. So the discriminant is equal to b is negative 2 squared minus 4, a is 1, and c is k. And so we have the discriminant is equal to 4 minus 4k. Oh, have I done a sign diagram with you yet? I don't remember. We're going to do it now. Okay, so we're going to ignore this for right now. So what we need to do is we need to say, okay, what happens when this 4 minus 4k is equal to 0? So when I do that, negative 4k is equal to negative 4, k is equal to 1. And what we want to look at here is here's our sign diagram. So when in this equation, here's 1. And when I come back to here and plug in 0, for example, do I get a positive or a negative? So when I plug in 0, I have 4 minus 0, and that's a positive value. So everything on this side is going to give me a positive. Try plugging in negative 100. That gives me a negative, when I plug in a negative 100 for k, then I get positive 400 plus 4 is positive. I don't really care what the number is, I just care that it's positive. And then likewise, I'm going to get a negative over here, but let's see what happens. When I plug in 2, then I have 4 minus 4 times 2, that gives me 4 minus 8, that gives me negative 4, that's negative. So everything over here is going to be negative. So this, ladies and gentlemen, is a sign diagram. I might have a whole worksheet on that. Now I'm thinking about it, and I'll go look and see how distance learning is going to get me. Okay, it's fine, it's fine. Okay, so now let's answer the questions. So A says two distinct real roots. So that means we want to know when is the discriminant positive but not equal to 0. Okay, so if I look back at this chart, when is it positive? It's positive from negative infinity to 1, but it would be equal at 1, so we're going to do a soft bracket. IB style is weird. Did we talk about that? I don't remember. Anyway, they like to do their brackets like that. I prefer this, but, just in case you see the other. Then the next one, two real roots. Now this, it looks like A and B are similar, but what it's allowing for is the fact that you could have one root repeated, therefore that's two roots. It's just the same thing twice. I hope that makes sense. And that's negative infinity to 1, but we're going to include 1 this time. C is a repeated root. And we get a repeated root when the discriminant is equal to 0, which in this case is when k is equal to 1. And then lastly, when would we get no roots? No real roots would happen anytime we are bigger than 1, so from 1 to infinity. Okay, hopefully that made sense. There is a second video that works through that problem that I scratched out right there. And let me know if you have questions. Oh, I think my answer key has all of this. This was just a review for you. Do it or don't do it, it's your choice. All right, good luck.